Hello everyone, welcome to DevScoop. This is Pranit, your host for the video. This is the first video on this channel, so I decided to choose a topic which, if you learn, will help you a lot later on during your project, especially in a team environment. So today, in this video, we're going to learn about Git and GitHub. To start off, you must be wondering what is Git and why should you use it? Well, Git is a distributed version control system. A version control system tracks changes to computer files over time so that when needed, we can recall any specific version. Distributed because every contributor maintains a local copy or clone of the main repository. So at any instant of time, if both the local copy and the main repository are in sync, they will share the same set of files. The benefit is that Git allows a team of people to work on and edit the same files of a project altogether. So you can imagine a scenario where multiple people are working on the same project. There will come a time when two or more people will be modifying or editing the same file. That will lead to some confusion, and Git helps us cope with this confusion. Before we start off, I would like to say that if you are hearing the word Git for the first time or have heard it but never used it, then this is the perfect video for you. For those who already know Git, this video will probably brush up your existing knowledge if you haven't used Git for a long time. With that being said, let's do it. So to start using Git on your local machine or system, you first need to install it. To install Git, you need to open up your preferred browser, which in my case is Google Chrome. Next, you want to type in this link git-scm.com. I will provide this link down in the description box, or you can type Git in your search bar, which will lead you to this website. This is the official website for Git, and now we need to go to the download section. In the download section, you have multiple options. For Mac users, you can use your homebrew package or any other package that you have installed on your system, or you can download the installer from here and unpack it. For Linux users, the Debian users, you can use sudo apt-get install Git. It's that simple. That will get the job done. For Windows users like me, you need to click this link, downloads for Windows. That will download the installer for you. Now I have already downloaded the installer beforehand, so I will cancel this download. Make sure you complete your download and open up the folder where you save this installer, in my case downloads folder. You want to run this installer in administrator mode. Make sure that you're doing so in administrator mode and follow what I am doing. Click next. If you want to change your installation directory or path, you can give a new path. I will keep it to default. Leave the options default here, git bash here, git GUI here. Next, click next. Here you have multiple options. You can use Git from your git bash terminal only, or which is the first option, or you can use Git from both git bash terminal and command line, that is Windows command prompt. So I will leave it to the default option, which is this, and the last option is basically it adds optional Unix tools, which is not required, so I'll leave it to the default option. Next, just click on next, leave it to the default option. Yes, I want Unix style endings and use min tty. Yes, Just leave the default options, enable file system caching, enable Git credential manager, and just press install. It will take around a minute to complete this installation. Now, as the installation completes, you would want to open up your preferred text editor. I will open up Sublime Text. You can use Atom, Notepad++, whichever suits your need. Uncheck View Release Node and check Launch Git Bash. You can also access this terminal anywhere from anywhere by right clicking, and here you will get Git GUI and Git Bash. Now Git comes in both GUI client and command line interface, as this is the command line interface, you are seeing it, and you also have Git GUI client. As a beginner, you will be inclined towards GUI client because you might think that it's easy. Yes, it is easy. Even the command line interface is easy, and you will soon see that. But as a beginner, I would recommend sticking to the command line interface, especially for this tutorial. You will learn all the basics that you need to know about Git, all the operations, basic commands, and how Git basically works. And once you have a good idea and you have learned the basics of Git, later on you can use any of these options to your preference. Like you can use Git GUI client, you can use Git Bash here, whatever suits your needs. So this is the command line interface that you are staring at, the famous black screen. Don't let this freak you out. So the first thing I want to do is to check whether Git is properly installed on our system and we can access Git commands from our terminal. So to do so, you need to type in git -- version. That will return the current version of Git installed on your system, which might differ from mine depending on when you install Git. Also, I want to make sure that Git commands can be executed from Windows command prompt apart from this terminal. So to do so, let's type in the same command here, git -- version, and that should return the same version. So you see Git commands work from both Windows command prompt and this bash terminal. So I will close CMD and stick to bash terminal for this video. Now the next thing you want to do is create a folder where you want to create your first repository. So in my case it will be desktop. Here I want to create another folder within Git projects, which I will use as my first Git repository or directory. So let's name it test dir and move into this directory. So open up the Explorer. Here you see Git projects and test dir. Now the first command which we will learn today is git init. So type in git init. What this does is to create an empty git repository in this current working directory or tree, and that will create a .git folder, which is a hidden folder. So if you don't see this .git folder, make sure that you have hidden folders view enabled. For Windows 10 user, it's very easy. Go to view and make sure that hidden items box is checked and file name extensions box is also checked. So now that you see the .git folder, this is nothing but the folder that Git uses to track all your files and folders and the commit history of this current working tree. So let's not mess around with this folder. If you destroy this folder, that is delete this folder, then it will remove the source control from this directory. Again, you can reinitialize the source control on this particular directory or anywhere on your computer or PC by using the same command git init. Now since this is the first time you're using Git, need to set up your username and email, that is user.name and user.email, so that you can make commit, which will make sense soon. So to do so, you need to type git config and make sure that -- global flag is added, so that every time you create a Git repository or initialize a Git repository, you do not need to do this git config user.name your username and git config user.email your email. So -- global takes care of that. It globally adds to the config file user.name. I will type in my name, make sure you type in yours, and git config -- global user.email. You can give the email within quotes or without quotes. I will give in within quotes. This is the first time setup because we are using the -- global. Next time we don't have to go over this procedure, that is config procedure. If you want to view the config file to make sure that the changes is permanent, you can do so by git config -l. So here you see we have added two fields, user.name and user.email. The next thing we are going to do here is create a readme.txt file. We can do so directly from the command line by typing in touch readme.txt. That will create the file for us. Now the next command we are going to learn here is git status. What git status does is it show you the current status of your working tree or working directory. So git tells us that it have an untracked file named readme.txt. So any change you make to this readme.txt file, let me open it in our text editor. So any change you make in this readme.txt file, Git will not track it. So to make sure that Git track any changes you make to this readme.txt file or any files in your repository, you need to add it, and this is called staging. You need to add this readme.txt file to the staging area. We can do so with our next command, that is git add, and we can type in our file name. This will add the file to the staging area. Now if we do git status again, we see that the file is being tracked by Git. Now we need to commit some changes we made to the repository. So to commit some changes made to the repository, that is to record the changes you made to your repository, you need to type in another command, which is our next command that we will learn, is git commit. Now if we leave it here, that is git commit, and press enter, it will take you to a weird looking screen which is actually styled like a Vim editor. To type anything in this screen, first you need to do is press I to go into insert mode. Now you can type your message. So I will type added readme file. Now this is actually helpful for multi-line commit message. So I can press enter and type in another line and again press enter. So this is good for multi-line full-blown commit message, but we will write only one line. So once you have done writing your commit message, press escape and WQ, which will save the change to this file, and quit from the screen. So you see added readme file, this commit message has been written. So now we do git status again. We see that nothing to commit and working tree is clean. The next thing we are going to do here is add in some more files. So let me add index.html and also index.css. If we do git status again, now it shows two untracked files, index.css and index.html. So we have to add it to the staging area again. Now instead of adding each and every file one by one, that is git add index.css and again doing git add index.html, we can add all the untracked file at once by doing git add dot or git add -a. Both will do the same thing. We can also use wildcard entry like star dot extension name. So from the list of untracked file, it will only add those files which have HTML extension. So if I do .css, it will only add those files which have .css extension, and it will leave the rest in untracked mode. So let's do git add dot, which will add all the untracked file to staging area. So we have to commit the changes we made, so we can check it again by git status. And this time I will show you a shortcut. Instead of going into that Vim like screen, we have to type in git commit -m and within quotes your message. But say if your message has something like it's like it single quote s again. Now this single quote will mark the end of message. So instead of enclosing your message in single quote, you can always enclose your message in double quotes if you are going to use this kind of words in your commit message. So let's write added index.html and index.css files. Now you see the commit message has been written. So we can do git status again, and it shows the current working directory or tree is clean. So the next thing I'm going to show here is that how this git status actually works. Now as I said, git status only shows you the status of the working tree at that particular instance or moment when you run this command. So let me make some changes to readme file. So if I type in some content like instruction 1 and instruction 2 and save that file, and we do git status, you see modified, we have modified the readme.txt file. Now let's add it to the staging area by doing git add dot, that is add all. And now instead of committing these changes that I have made, that is instead of writing git commit, we are going to again make some change to this readme.txt file. So let's add some new content or new line and write instruction 3 and again save it. Now let's do git status again. Now you see readme.txt file is being shown under both changes to be committed category and changes not staged for commit. So it is there in both section. This is because the first time when we did add it to the staging area, we did not commit it. So the status of that file at that instant was that it was added to the staging area but not committed, and the next time we did it is we did not add to the staging area but the file has been modified. So that is why this is being shown in two places. We can do a shortcut here in commit message. Instead of writing git add two times, that is git add -a and -m, and write our commit message, that is added now. If I do git status again, it will show nothing to commit, working tree is clean. So this is how git status work. Now let's say that you have some files in your directory such as log files and other type of files that you don't want git to track, or you don't want them to end up in your repository. In that case, what you need to do is you need to create a git ignore file. So before we create a git ignore file, let's create a touch log.txt file. And now let's create a .gitignore file. Now you cannot create this file directly as you normally do, because it's a .ignore file, so it will be treated like an extension. So if you do something like .gitignore, it will show you must type a file name, so this will give you an error. So let's do it directly from the command line. That will take care of that problem. Touch .gitignore, so it created a .gitignore file. Now let's open it in our text editor. So whatever you write here, that whatever the file names or directory you mention in this .gitignore file, all these files and directories will be ignored by Git. So Git will not track these files. So whatever files like log files or any other files in your project, if you don't want Git to track them, you must include them in a .ignore file. So in my case it will be a log file, so log.txt. You can again use wildcard entries like start.txt file. It will exclude all files ending with .txt extension so that Git do not track those files. So let's leave it to log.txt. And now let's do git status. So you see it only shows .gitignore file, but it doesn't shows log.txt as an untracked file. But if we remove log.txt from this gitignore file, it will show up in this untracked file list. So Git is not tracking our log.txt file anymore. So let's add it to staging area and commit. Now let's learn another command, which is git log. So what it does, it shows you the history of all the changes you committed. So if I execute this command, so it shows me all the changes I committed. So from the beginning, that is, we added index.html file, then added contents to readme file, and lastly we added .gitignore file. Here the author name will be given, that is the user.name and the user.email, so that you easily understand who made what sort of changes to your repository. So the next thing I want to talk about is branching. So imagine yourself working in a team project and each contributor has been assigned different sort of tasks. Say you have been assigned some feature to work on, so you have to develop that feature and then add that feature to the existing project. And say your partner, that is your team member, has been given another feature to work on, so he will work on that feature, and after his work has been completed he will add that feature to the current project. So consider this master branch as the main repository. You don't want to be making any changes directly on the master branch. What you don't want to do is to connect to the main repository and start making changes to the current files. Now if you make any wrong changes there, or if your change adversely affect any other working section of that project, then it will affect each and every contributor of your team. So what you need to do is create a branch for yourself. Creating a branch here means you actually copy all the contents of the main repository into your branch that you have just made, and in that branch you can make all sort of changes. You can add necessary files that you want to add, additional files, or you can modify existing files, but whatever changes you make will be localized into your current branch, so it will not be reflected on the master branch, nor it will reflect to any other branch of your other team members. So in that way, any changes you make will not affect any other contributor of the team. So it's an independent working setup, and once you complete your work on that particular branch, that the task you have been assigned, once you are finished with that, you just merge all the contents of your branch to the main repository. That will reflect all the changes you made, and the main repository will be updated. So that is how you work in a team project. Each and every time you are given a task, you create your own branch, you work in that branch, make all sort of necessary modifications you want to make. You then want to make sure that others review that branch, that everything is working fine, and once everything is reviewed and perfect, you merge back to the main repository. So let's learn branching. So the command you need to learn here is git branch, and you need to give a branch name. So a particular repository may have hundreds and thousands of branches, so you have to give a branch name, and generally it should be a meaningful name, but here I will just choose a random name, say my branch. And to move into this branch you need to learn another command, which is git checkout the branch name, that is my branch. So you have now moved into my branch. So you can see it here currently, that is, this is the branch. You can also do git branch. It will show all the branches that is available to you, and asterisk and highlighted one is the branch you're currently in, that is my branch. Now in this branch you see all the files that I had in main repository, that is master branch, is still there, and even the contents are same. So I can start making changes here. So I can add another line in readme.txt file and save it, and let's create another file, say index.js, and let's check our status of this branch. So I have a modified file and an untracked file. So let's add it to staging area by git add all. So we need to commit the changes by typing in our commit message. Make sure you write meaningful commit messages. If I write in here made changes only as a commit message, it doesn't make sense to anyone. If anyone sees the commit history of a file, he won't understand what sort of changes you made to that file. If you say that made changes, that is not clear what sort of changes you made. So you have to be very specific, and your commit message should have some meaning, so that if anybody looking at your commit message can straight away understand, yes, you did something important, you did this sort of changes. So now let's check the status of a branch again. So it's on branch, my branch, nothing to commit, working tree clean, so everything is fine. Now let's check out to master. We can switch our branch, that is switch from master to branch and branch to master. So in this case we need to write git checkout master, because that's our branch main repository. And you see there are two changes. First of all, we don't have the index.js file, and also if I click here in the sublime text, you see in instruction 4 that line just vanished. So what I said is that any changes I made to that my branch files are localized, so that remains within my branch, so it is not reflected in this main repository, that is master. So all the changes across branches made are independent. So now that we have done our changes in my branch, now we want to merge all the contents in my branch to master. To do so, you have to first make sure that you are in the destination branch. That is, in this case, I want to merge from my branch to master. I have to be sure that I am in master. So you can again do so by checking git branch, and that will show you that yes, I am currently in master, and you can also see it here. So it is very important that you are in your destination branch. And the next command that you need to execute to make sure that you merge the content of some branch to another is git merge. Here after merge you have to mention the branch name. So in this case we have my branch. Now you see whatever was there in my branch, it has been merged to the master. So now we have index.js file, and now if I click on readme.txt file that is open, we will find the missing instruction 4 available. So that is how you do branching and again do merging. Now most of the time there will be no issue during merging, but sometimes you will run into merge conflicts. So let's try to recreate a merge conflict error. So what I want to do is add another line in readme.txt and type instruction 5. Now that I have staged and committed the changes, let's switch back to my branch. Here, let us add instruction 6 as the new line, and again stage and commit those change. Now remember the shortcut I told you, that is git commit -a -m. This will skip the staging step, and remember this will only work for those files that git is already tracking. So any new file you add, you have to manually write that git add command again, but those files that are already been tracked and modified, you can use this shortcut. Now this time let's try to merge master into my branch. So you see we are in the destination branch, that is my branch, and we just have to write git merge. We want to merge master, so git merge master, and there we go, merge conflict error. And this is the type of error that git cannot resolve automatically, so you have to manually fix this error. So let's try to look at the file. Now this top portion, that is head, refers to the version of file in the current directory. That is, the current directory is my branch, and in my branch the version is instruction 6, and the bottom part, this is the version of the file from the source directory, and the source directory here was master. So in master we had instruction 5 in the same line as we have instruction 6 in my branch. So git is confused, so git does not know how to resolve this, because both instruction 5 and instruction 6 appear in the same line, so you have to manually fix this error. So to fix this error, you can either delete instruction 5 and keep instruction 6, or you do it the other way, delete instruction 6 or keep instruction 5. But I want to keep the instruction in sequence, so I know what to do. So change this to 5 and change this to 6 and delete remaining markers that was provided to help you fix the error. Now you can imagine how this type of merge conflict error will occur in team project. It's not that you cannot avoid this type of error, but if you are well connected and there is good communication amongst the team member, this sort of merge error can be avoided. But if you don't share such good communication among team members, this type of merge conflict error might occur. So you have to then manually fix it. So now that I have fixed my merge issue, let's do git commit and let's see the status, and there's no problem. So the issue is fixed, and this is how you resolve manually merge conflict errors. The next thing I want to talk about is stash. So how does stash help you? Well, given that I am in my branch and say that I create a new file, and let's name it new file.txt, and let's stage it. Now suppose I am not ready to commit this change to my branch, but I want to switch back to master, which is a clean working directory or branch. Then what I can do is save the current state of my working directory in a stack, and then I can switch back to master. After I finish my work in master, I can again switch back to my branch, and after it is finished, I can and now I can resume my work again by doing git stash apply. But before we do that, let me show you how stash really works. Let's say we create another file, say new file 2.txt, and I again do git stash. I'm sorry, I have forgot to stage the file, so I have to stage it. Now I can do git stash again. Remember, you have to stage the file. Any new file you add or any modification you do, you have to stage that modification or change and then do git stash. So see that new file 2 totally vanished. So it saved the new state of the current working directory, and remember this state is different from the one that we saved a bit earlier. So in that state we had all this current file plus new file 1, I guess, or just new file. But in this state we have all the current file and we have all the current state, new file.txt, and another new file which we created just now, new file 2.txt. So if you want to look at the current state of this stack where all the saved state are being stored, we can do so by typing git stash list. So here you see we have two states, that is the one where we had new file.txt and another one where we added new file 1.txt. Well, this is just like file versions. So these are two versions of your current working directory that you saved. You can go back to any version you want. So if I do git stash apply, and remember it's like stack, so the last state you saved, it will be the first one which you will get back when you do git stash apply. So that last in first out principle. See, we get back new file 2.txt. So that was the last state we saved. But if we do git stash apply again, it will keep throwing us the same state, that is this all those files plus new file 2.txt. To get back the state earlier to that, we need to remove this state from the top of this stack. To remove this state from the top of this stack, we can do git stash pop. So this state has been dropped from the stack. Now if we look at the stack, that is git stash list, there is only one state, and that is the first state we saved. Now if we do git stash apply, we'll get back new file.txt because that is on the top of the stack. Yes, we got back new file.txt. So this is how stash work. You can create different versions of your current working directory, all those changes that you have not committed yet, and you can switch between them. Now let's commit those changes, that new file.txt and new file 2, and doing git status, our branch is clean. Now we can remove any file or directory from source control. We can do so by typing the command git rm and the file name we want to remove or the directory name. In this case, say it should be new file 2.txt. So new file 2.txt has been removed. If we do git status again, we have to commit this change that we have deleted a file from repository, that is git commit -m or -m. We can also rename any particular file to another name by doing git move. So it's basically a simple one, just like you do in Unix or Linux environment. All this while we were working with a local repository. But now that we learned the basic commands of Git, it's time to move on to work with some remote repositories. To work with some remote repository, we need an online platform where we can create those repositories and store all those repositories, and whenever we need, we just need to connect to these remote repositories and update our local repository with the contents of a remote repository. Now GitHub provides us this type of platform. So let's open up our browser and go to this link, github.com. And once you reach this website, if you don't have a GitHub account, you can just fill in this form, that is username, provide your email and your password, and just click sign up for GitHub. That will send the mail to the mail ID you provided here, and you just need to confirm your mail ID for your GitHub account. And once you do so, you just need to sign in to your GitHub account. Now once you are signed in to your GitHub account, you want to create your first remote repository online. So you want to click start a project, and here you want to give your first repository name. I will type in GitHub demo, and here we have option to make our repository public and private. By default it is public, and remember, private repositories are paid, so you have to pay some amount for each and every private repository that you want to have. And there is another online platform like GitHub, very similar to it, which provides you free private repository. So if you want to check out that platform, you just need to go to bitbucket.com, and basically both GitHub and Bitbucket are very similar to each other. And here if you look into their features, they say unlimited private repositories, so you can create private repositories for free, but there is a limit. You can only add up to 5 people including yourself for a team project. So you can only have 5 collaborators, and if you want to have more than 5 collaborators for your project, you need to pay for that. So you can look into this Bitbucket if you want. For this video we want to stick to GitHub. If you can operate GitHub, you will have no problem with Bitbucket, and if you can operate Bitbucket, you will have no problem with GitHub. Both uses Git and works almost the same way. And here we have options to initialize our repository with a readme file, but I won't because I already created the readme file offline, which I will upload here. And you can also add your .gitignore file. So GitHub will add this .ignore file to this repository if you want, and then there you can add all the files or folders that you want to exclude from tracking. You can also add a license which will be suitable for your project. There are numerous licenses provided here, but since this is a demo repository, first online repository, I will create an empty remote repository. So we just need to click create repository, and once you do so, here they have already provided you the instruction that you need to follow to connect to your remote repository. But remember, although we'll be working with a remote repository, we'll be ultimately working on a local machine. So we'll be just be in sync with the remote repository whenever we need. To start off, you just need to copy this link. This is the link to your current remote repository that you just now created. And once you copied that link, but before we start off, I want to mention that I created another Git repository that is named demo, which does not have many files. It just have a index.html file and a readme.md file. This index.html file is a basic HTML file which have a title, a header h1 and a paragraph, and a readme.md file where MD stands for markdown. This is the local repository named demo, which we will upload to our Git demo remote repository. Given that you have learned the basic commands of Git and have created your first offline repository, you can easily create another one. You can populate with any file you want. You can add more files, you can add only one file, whichever type you want for your first demo repository. In this markdown hash basically means that it's a header. So one hash suggests that it's h1, that is equivalent to h1 in HTML, and 2 hash suggests that is equivalent to h2 header, and 6 hash will suggest that it's an h6 header, and the text enclosed within double star will make that text bold. If enclosed within single star, it will make it italic. So let's jump into bash terminal, and the command that we'll be using today is git remote. Now git remote shows you all the list of remote repositories that you are currently working with. Now if I execute this command, it will show none because we don't have any remote repositories currently connected to a local repository. So to add a connection to a remote repository, you just need to type git remote add, and here you have to give an alias name, but let's stick to what GitHub uses as default, which is origin, and then you want to paste the URL you copied, that is the link to your GitHub project. Now this will add git demo to the list of remote repositories. Now if we execute git remote again, it will give us origin. If you want to know which remote repository is represented by the alias name origin, we just need to do git remote -v. So for fetch, we have origin as alias. What alias does is that while executing commands such as git push, git fetch and git pull to communicate with a remote repository, we don't need to provide the full link to the remote repository that we'll be currently working with. So in place of full link to your GitHub project, we are going to use origin as the alias. So now that we created a readme.md file and we have a index.html, we can push the contents of our local repository that is in demo to git demo. So to do so, you need to do git push. What git push does is that uploads all the contents of your current working directory to your remote repository. So git push, here you need to mention origin and master. So you see, we're using origin in place of this full URL, and what we are doing here is that we are saying Git to push all the contents in this demo folder that is in master branch to our remote repository whose alias is origin. Now since we are doing this for the first time, we need to add a flag that is --set upstream, which will make sure that GitHub correctly uploads all your files from your local repository to origin. So the upstream, that is the flow of data to your remote repository, you have to set it for the first time. Here you can also use a shorthand to this big name, that is -u. Both basically means same, that is set upstream. And once we do so, and here you see GitHub uploaded our files to remote repository, and hopefully all these files, that is index.html and readme.md, will be now present in Git demo. Make sure that you have internet connection, because while you are communicating with remote repository you do need an internet connection, and maybe you will be prompted with a GitHub window on screen where you have to put in your credentials, that is username and password, to make sure that this push operation completes. Otherwise the upload will not be successful. So let's check our repository, and there you go, we have index.html file uploaded. And if we open this file, it have our HTML code that we had written, and we also have our readme.md file that is formatted in markdown, this readme file. And as you see, this is a header, this is a italic plus bold text. So this is how you upload your content to a remote repository. Now let's try to edit one of these files. Let me edit index.html here in GitHub, and I will just add Git demo here. I will just change the title, and down here you need to put in your commit message. So I will say updated title. Now you can add additional extended description, like this is a short message, you can add additional description to it, and commit directly to master branch. We don't have any other branch created now, so yes, commit directly to master branch, and you just need to click commit changes, and that will make the change. And now let's go back to the main repository, and next we'll learn another command. So let's minimize this, and now the command which we will be learning is git fetch, and we will put in our alias name, that is origin. So we want to fetch from origin, and what fetch does is that it downloads all the files from remote repository down to your local machine, but does not merge them to your local files. If any change is made to the remote repository by someone else, the first thing you want to do is git fetch. So by doing git fetch, you can understand whether the remote repository got updated. So let's do it. Git fetch origin. So we made change to our index file, and if we look into our index file on our local machine, our title is still demo. So to make sure that you get updated with the modified contents of remote repository, you need to do git pull and origin as our alias. So we pulled from our remote repository and the changes will be reflected on our local file now. So if I do index.html, yes, now we got a new title, that is git demo. So let's create another file in our local repository. Let's name it index.css. I will keep this empty and just do git add to stage this file and then git commit and check our status of our master branch. And here it says your branch is ahead of origin master by one commit. That is, we have done one more commit to our local copy with respect to our remote copy. So if we do git push, and this time I will only do git push, I can type in origin or I can ignore it because I already set an upstream link to a remote repository. Remember the first time we did git push -u, that took care of this upstream link connection. So now we can just do git push to get our job done. And if we refresh here, we have our index.css file. Now let's learn how to clone a repository. Cloning a repository means copying all the contents of that repository onto your local machine, that is, onto your local Git repository. I will clone the Git demo repository that we created in this video into my Git projects folder. You can clone it to anywhere on your local machine. So make sure you are in the desired folder. So to clone a repository, you need to open up that repository in your browser and grab the link to that repository from here. You can also download this entire repository as a zip file and extract it to anywhere on your local machine. Once you have done that, let's go back to the git bash terminal and type in git clone followed by the URL you just copied and press enter. Make sure that you have your internet connection during this process and see the entire Git demo repository got cloned into Git projects folder. So let's move into Git demo folder. Now let's make one change to our Git demo repository online. That is, we want to delete this index.css file from this account. You can see the latest commit was revert deleted index.css, so I accidentally deleted this file earlier, so I needed to restore this file. So let's again delete this index.css file. Just delete this file and make sure you write a commit message. And just commit changes. Now go back to the terminal. Now I need to update my local repository with the change I made in my remote repository. So I can directly write git pull, which will download the remote repository and merge all the changes into our local copy. Or we can do git fetch, which will download all the files but will not merge the changes into a local copy. Once we do fetch, we can do git status, and that will say that we are behind by one commit. That is, we have done one more commit in remote branch with respect to what we did to a local copy. So you can do git merge, and remember, git pull is basically the combination of git fetch followed by git merge. You can directly do git pull if you want all those changes to reflect on your local copy, or if you are not ready yet to merge all those changes made to the remote repository to a local copy, you can always do git fetch. And then when you are ready, you can follow it up with git merge. So let's do git merge and see our index.css file got deleted from our local repository. Now let's open this index.html file and make a quick change. I want to change the header tag from h1 to h2 for a small header and save this file. If I do git status, I need to stage this change, or we can do git commit followed by -a-m and the commit message. Now if we do git status again, we are ahead by one commit. So we want to push this change onto a remote repository once again. We can do so. Before we do so, let's check our remote links, and we do have origin as our alias. So we can directly do git push here, and that will merge all the change I made here into my remote repository. So let's check our remote repository, refresh, and let's open index.html. Yes, we have the change from h1 to h2, the header tags. So this is how you clone a repository. You can clone a single repository into multiple copies, as many as you want, and make all sorts of change you need in your local copy, and when you're ready, you merge back all those changes to your remote copy. You can also do another thing. Say that you cloned a repository from someone else and made your own changes, and now you want to upload this local modified repository of yours into your GitHub account. You can do so by setting up a new alias. So remember how we set up a new alias? We do git remote add the alias name, say my repo, and the link to your repository. So you paste here the link to your repository and press enter. That will add my repo as the alias to your git repository, and obviously origin will refer to the repository that you cloned. So when you need all the changes that has been made to the source copy, that is the repository from where you have cloned, and you want to push all those changes into your repository, you can do git pull and type in origin. That will pull all the changes made to the source copy, and after you pulled all those changes into your local copy, you can do git push, and here you give the alias name of your repository that you created, that is git push my repo. So you pulled the changes from the copy you cloned from, and you merge those changes into your copy, that is your repository in your account. And that's how we clone a repository and work with it. So in this video we covered most of the basic commands that we will be using frequently for our projects. There are other commands available which you can check anytime by typing in the command git -- or -- help. So this will list all the available commands that you can use in Git. Just to remind you, in no way we have covered all the functionalities available in Git. We can do lot of advanced operations in Git using these commands and some more commands that you can see from this list. But we have learned most of the basic commands of Git, and these are the commands that you will frequently use for your projects with respect to the ones that we did not cover. And whatever we covered in this video is good enough to get you started using Git for your future projects. That's it for this video. Hope this video helped you learn Git and GitHub. Please do like and share this video. Do leave a comment below giving your feedback, and if you want to see more content like this, then don't forget to subscribe to this channel. So see you in the next video. Till then, stay classy and goodbye.